All right, today we're going to be talking about soil formation. When we talk about the layers of soil, we call them horizons. So they're going to be lettered, and they're going to start up here with A, which is going to be the top layer of our soil, and we call that the top soil. It has a high organic content and some weathered bedrock. But it has a high organic content because that's where the plants are dying, the animals are dying, and they're decomposing and adding that organic element to our soil. B horizon. This is partially weathered bedrock with some organic material. Our amount of organic material is decreasing as we start to move down through the horizons. And C is partially / slightly weathered bedrock. There's no organic material in this one. It's mostly just broken up bedrock. Finally, at the bottom, we get our bedrock. That's what all of this soil is going to be resting on. So you can see here is a profile of our soil, and we've got our parent material down here. This is the underlying bedrock and big chunks of that bedrock. And as we start to move up, the amount of organic material is going to start to increase, and the amount of parent material and rock is going to start to decrease. Also, it's also going to have lots of water and air in the higher layers, the higher horizons, than it is down towards the bottom. So, two main components of soil, weathered bedrock and organic material, but there's also going to be some water and air as well. And what is the difference between transported soil and a residual soil? So a residual soil matches the rock below. It's made from the bedrock. A transported soil was brought to the area by one agent of erosion, typically glaciers. Our soil here was brought here by the glaciers at the end of the last ice age. So what is erosion? Erosion is the removal and transportation of sediment. And we have 4 natural agents of erosion. They are water, glaciers, wind, and gravity. We got 2 W's and 2 G's, right? Water, wind, glaciers, and gravity. Those are the only 4 things that are going to be actually moving our sediment. So let's start with gravity. So gravity causes mass movements. This is the pulling of rocks and sediments downhill. Some examples of mass movements include landslides. So landslides are when we have a mixture of rock and soil that slide down some sort of hill or mountain. You can see right here, this is a landslide, probably caused by excess rain. As the soil and the rock gets saturated with water, it becomes much easier for it to slide. Another one we have is soil creep. So soil creep is usually just involving soil, and as it slowly slides down the hill, it can change things on the landscape. So landslides are really dramatic, right? They happen fast. Soil creep is something that's going to happen over a long period of time, and it's just going to slowly move down the hill. So mud flows or mudslides. This is when there's a lot of water in the soil, right? And most of it is water, and it's got some soil in it, and that's what's causing the slide. Rockfall or debris fall. So this is when there's very little water and it's mostly just rock. We see these oftentimes in mountains when we've got rock falling off the sides of cliffs. If you've seen these signs before traveling through the Adirondacks, there's been rock slides in the area. And you see right here, we got a rock slide that's blocking this road. And if you ever see, there's a lot of times, there's wire mesh netting, steel netting on the side of the road that's designed to catch some of the larger rock slides. Avalanche is another type of mass movement that involves snow, but that can actually affect the landscape, right? Enough snow moving down a mountain can break up trees, it can move sediments, it can do all sorts of things. So here we got an avalanche. It's mostly just snow moving down the side of a mountain, but it can also affect the landscape. Rocks eroded by gravity appear jagged and broken because this is something that happens quickly. Remember when I talked about water moving sediment? It happened over a long period of time, and it broke up the rock and it caused it to be more rounded. The opposite's going to happen here. It's going to be very jagged because it's going to happen. The rock's going to fall off the side of the cliff, smash on the ground, and that's it. It's not going to move again. So it's going to remain very jagged. All right, let's talk about wind erosion. So deflation, this is one type of wind erosion. It happens when the wind carries away loose sediments and lowers the Earth's surface, right? What's happening is it's going to move the light stuff, the small pieces, but it can't move the larger pieces. So that's going to cause those larger pieces to stay put. But because all that material is moving somewhere else, it's actually going to lower the elevation. It's going to lower the surface of the Earth. So you can see here in this picture, these trees once had roots going down into the soil. All that soil has been moved away. This was that sandy stuff that we see right there. Sandblasting. This occurs when wind blows sand or silt against other rocks, causing the rock to appear pitted, like a golf ball. So we can see in this example right here, this rock has been eroded by wind coming from this direction, because if you look and see, this side of the rock has been broken down and its shape has changed. It can tell us what direction the wind is coming from. So here's some pictures of sandblasting. You can see the bottoms of these are much smaller than the top because it takes a lot less energy to move the sand a little bit off the surface of the Earth compared to really high. So way more sand and way heavier sand is going to hit the bottoms of these, causing more and more erosion. Now, as this continues, eventually the top is going to become much too heavy and the top is going to topple over. All right, let's talk about glaciers. So, as a glacier moves over land, loose rocks and sediments freeze within the ice. These rocks help the glacier to scratch and carve out the land below, producing glacial grooves and parallel scratches on the rocks called striations. These scratches show the direction of the glacier movement, right? So we can find these at the tops of mountains in the Adirondacks. We can find them all over the place. These scratches that show us what direction the glaciers have been moving. These rocks appear what we call sub-rounded. They're boat-shaped, and they are scratched, right? They're not rounded like we see with water, with rocks that are changed by water. They may have one side that's nice and rounded, and maybe the other side's, a little bit more jagged. So here's an example of those striations. You can see these grooves that have been carved into the rock, showing the direction of the glacier. Here's an example of a glacier forming. This is an alpine glacier forming in the mountains. You can see it's starting to flow down the side of the mountain. All right, let's talk about erosion, water currents, and waves. So, because waves strike the shore at an angle, the water near the shore is pushed in one direction along the shore. This causes a longshore current. So, sediment is going to be moved in one direction down the shore. So as you can see, these waves are not hitting perfectly straight. You can see this if you ever go to Charlotte Beach. You can see as the wave comes in, it's going to hit at an angle, and if you watch any of the sediments as they move, they're going to go up at an angle and then go back out at a different angle. And as that occurs over and over again throughout the year, sediment is moved in one direction down the beach. All right, let's talk about running water. So any running water that is confined to a channel will be called a stream. I know we have brooks and creeks and all rivers and all that. We're going to call them a stream because we're not differentiating between any of those because they all kind of work in the same way. All right, streams as agents of erosion carry sediments in a couple of different ways. In solution, right, you can have things that are dissolved in the water, or suspension, they could be floating by rolling and bouncing along the bottom of the stream. These sediments become rounded. As they continually roll and bump against other things in the stream, they become more and more rounded. They lose all those jagged edges.